Sound test. We're good to go. Hey guys, sorry about this late mess of a tutorial because I kind of realized halfway through today that the physics exam was on tonight, tomorrow morning. So in saying that, we're still kind of here and we'll get going. And for any level 3s that are here, I will try and do a tutorial Sunday for sure for you guys, okay? Tony, yeah man, just send the questions to that email address that I've given you there, because I've just been kind of sitting here trying to rack my brains of how to, like, what questions we can actually work with. So I've only got like 2 questions here today, just covering some quadratics. But after that, if you guys do have any more questions on top of that, you're more than welcome to actually just send a picture of the question, or just send the question to that email address that I've actually given you guys. Okay, so in saying that, as I said to you guys today, we're going to be doing a bit of quadratics. We'll start with question number 2 first, all right? Like, these are the 2 questions that I've written up today. So we've got a right angle triangle for question number 2, where we've got to try and figure out what x is. And then question 1, which is your classic, word problem with quadratic. Okay, Tony, I'll also wait for your questions, Tony. So, but we'll actually start with question number 2 first, all right? So yeah, feel free to send questions, guys. And just, I know I'm kind of looking at multiple screens at the moment, but if you did send a question and I haven't picked it up, just let me know in the comment section and I'll go find it. So we're going to start with this first question here. It's a nice kind of simple quadratic to start with. But it does require to remember you have to remember your, what do you call this thing? Pythagoras theorem, all right? Because if you remember your Pythagoras theorem from last year, you've got a, b, and h. So what you have is a squared plus b squared equals h squared. One I think I've done with the MCAT tutorials, man, but the tutorials are still there in the playlist, so you can go check them out. Give me a second, I'll do this question and I'll put a link up where it is. Jay, all right, Jay, I got your question. Give me a second, mate. I'll do this one and then I'll get on to the next one, all right? Cool. So what we've got here is we've got a squared plus b squared is h squared. So all we're going to do is we're going to replace a with 2x squared plus b, which is 2x plus 1 squared, and then h is 3x minus 1 squared. So that's my a right there, and then I've got my b, which is the 2x plus 1, and my hypotenuse, which is 3x minus 1, which ends up being there. So at this point, just expand the brackets, rearrange to a quadratic, and solve. You're good to go. So 2x squared is just going to be, see, I knew I was going to make this mistake. I always do this mistake as well. It's actually 4x squared, because 2x times 2x is 4x squared. Plus, I'm going to put the 2x plus 1, expand the brackets out. It's always a good idea to expand the brackets. Otherwise, you end up making some silly mistakes in expanding. So I've got 4x squared plus 2x times 2x is 4x squared. Kind of keep going on, 2x, and then I've got another 2x plus 1 equals 3x times 3x is 9x squared minus 3x. Got another minus 3x. Negative 1 and negative 1 is plus 1. Yeah, sorry, Infused, but look, man, I'll leave this, like, I'll leave the video up and running, all right? Like, I mean, it should always be saved. I do apologize for those people that have physics tomorrow. I timed it really badly today. But anyway, let's kind of finish this off here. So what we've got is simplifying the left-hand side. We've got 8x squared plus 4x plus 1 equals 9x squared minus 6x plus 1. Now our 1's actually disappeared because they're positive 1 on both sides. Bring all the x's to the other side, so we've got 9x squared. The 8x squared when it comes to the right hand side is minus 8x squared, and we still have negative 6x. And when we bring 4x to the other side, it's negative 4x. And so what we have is 0 is equal to x squared minus 10x. And I think I've given you guys a nice simple quadratic to work with. So we can actually just factorize this, and we're going to get x multiplied by x minus 10. So at this point, we can actually say x is equal to 0 or positive 10. Yeah, I think I chose some really nice numbers to kind of get started with. So in this case, we've actually figured out what x is, and then we can actually kind of ignore, we have to ignore 0. The reason we have to ignore 0 is because remember that our hypotenuse, so if you remember, our hypotenuse is equal to 3x minus 1. And if you put 0, then we're going to get h is equal to negative 1, and so you can't really have that. So therefore x is equal to 10, and then the dimensions, it's going to look like this. So that's going to be 20, and then that's going to be 21, and this is going to be 29. Mitesh, I'll probably be doing the next tutorial for calculus on level 3 calculus on Sunday, man. Integration, Mel, you just asked me the question on my email about integration by parts. Could you send me a question, because I haven't actually done it in like a few years, but I can maybe have a look at it after the live stream. Okay, let's have a look. So guys, is that all good with that question? Can we go back to question number 1? Flashed away, no, you're actually expected to remember formulas such as like, you know, you're actually expected to know this. They won't actually give you like a right angle triangle formula or anything like that. Williams, no, that's absolutely fine, because I mean this part right here is a quadratic here, so you could, I mean we're just factorizing it and solving it, but you can actually do that in it can be on both sides. Oh, hang on, did you say plus 10x? No, it can't be plus 10x. That means you've done something wrong somewhere. Oh no, sorry, I just saw that minus. Sorry, man. I just saw your equation. So your equation looks like this, isn't that correct, William? So it looks like minus x squared plus 10x equals to 0. Sorry, in the comment section, the minus is stuck in the first line. That's why I couldn't see the minus. Now this is absolutely fine, because if you factorize it, you will still get like negative x plus 10 equals to 0, therefore x is equal to 0 or positive 10. So it'll still work out. You're absolutely fine. So flashed away, going back to your question, remember like, I mean, you're expected to know area of triangle, area of circle, and I think just be aware with compound shapes. So when I say compound shapes, what I mean by is like sometimes they'll have like a, you know, like for example, a rectangle and a circle, or they might have a like triangle and a rectangle, like a trapezium, for example. They do that as well. Yeah, no worries, Micah. I kind of realized that halfway, about 7 o'clock today or 8 o'clock today, so it's okay. Okay, so let's, if you guys are okay with that, can I go to question 1, and then I'm going to do, Jay has sent me a couple of really quick questions. Jay, I'll add it onto the playlist. Eddie Parks, I've had a look at level 1 physics paper before. I think there's only one section which I can do pretty confidently. But the rest of it is like not really, man, because there's a lot of linear algebra stuff in physics. But maybe one day when I get some time, I think I'm pretty busy with level 1, 2, 3 at the moment. Okay, so if that's all right, let's just I'll tell you what, let's actually do a couple of quick easy ones just to get the flow going, and then we'll come back to this question. So I'm going to put up Jay's question up here. So these were two real quick questions Jay wanted to have a look at. So Jay, these were your questions. Let me just copy image. This is going to work. No. There we go. Couple of nice simple ones for you guys. Jay, now you can use the quadratic formula in the calculator, so you can actually use the calculator straight away. You don't need to actually show the answer. Like, you don't need to show the answer. You don't need to show the working, man. Okay, Jay, real quickly, looking at these questions, all right? The way I teach my guys to do it is this. I always take the number inside without a power and put a little 1 next to it. Because once I do that, then what I'm going to do is 8 to the power of 1 times 2/3, and then x to the power of half multiplied by 2/3. All right? Now, what you're going to get is 8 to the power of 2/3, and then x to the power of 1/3. Because half times 2/3 is just 1/3. Now, 8 to the power of 2/3, use the calculator for it. But really important that when you use the calculator, just make sure you put the power 2/3 in a bracket. Because if you don't put 2/3 in a bracket, then I'll show you what happens if you don't put 2/3. So this is the actual answer you're supposed to get. But if you don't put the brackets, then you actually end up with 64/3, and that's actually incorrect answer. All right. So in this case, the answer is going to be 4 x to the power of 3rd. Now this question is kind of nice because if you look at it, whatever you've written here is this part right here. Okay. So what we're then going to do is we're going to put square root. Because the yellow part is from the previous question, we can rewrite this as 4x to the power of 3rd divided by x to the power of negative half. So the first step you got to do is you got to combine the x powers together. So I'm going to have square root of 4x to the power of 3rd. And remember, when you divide the powers, you've got to actually subtract them. So there's going to be minus negative half. So in other words, it's going to be 4x to the power of 1/3 plus half. And again, don't waste time with, like messing around with fractions, because you do have your calculator. So just go over 1/3 plus 1/2, which is 5/6. And then, of course, when you have square root, it's the same thing as saying 4x to the power of 5/6 to the power of half. And we literally repeat what we did in the first question. So we've got 4 to the power of 1, 4 to the power of 1 times a half, and then x to the power of 5/6 times a half. Now 4 to the power of half is 2, and then x to the power of 5/12, which ends up being your final answer for that. So is that all good, Jay, there? All right, guys. It has a 8 on the top. So where's the x gone from the bottom? 8 on the top. Where has the x gone from the bottom? Which line are you talking about there, Samuel? I'm just going to put a couple of numbers so you can kind of guide me. So that which... yes, Taif, if you do have the picture of a question, just email it to me here. I'm just going to type in the email address again. 8x and 8x and x. Samuel, no, I think I'm just trying to figure out where your question is. I don't understand what your question fully is, Samuel, there, because which line are you talking about here? Oh, yeah. Okay, so basically, yeah, you're right. So this part here, so this is very similar to saying something like am over an, and then a to the power of m minus n. So that's all I've done. So is that all right, Samuel? Mitesh, I might just put it out, put a little, what do you call it, a poll just to figure out, because I think I'm supposed to be doing integration, but a lot of people wanted some differentiation stuff for level 3. But otherwise, I might just do like 3 excellence questions, like 1 from each standard. Sweet, we're okay with that. Yep. Eddie Parks, level 2 logs. I think I'd spent like a whole tutorial on that, man. Like, just have a look at the playlist on my homepage. There's full sessions just dedicated to logs. Okay, cool. Let's go to the first question, all right? And then I'm going to come back because I know Tony has sent me a few questions. Tony, I'll get to those questions, but I want to get to this quadratic question first. So, and I'll actually go through this one first, and then I'll go through Tony's questions after that. Yep, got it, Tony, got it. So I'm going to leave this question up for you guys for a couple of minutes just to maybe have a start, like just have a go at it. Just start off the question just to see whether you can get somewhere. This is definitely an excellence question, which I'm sure of it. But always remember, even for excellence questions, just doing like little bits and pieces can get you like achieved in merit. Sorry guys, just trying to sort out this next question while we do this. X squared. Where did it go? All right, here we go. Whoa. Squared 4x plus 2 have 2 different. Okay, so hoping you guys kind of at least had a bit of a rough start with this, but basically this is what's happening, all right? You got a vegetable garden has an area of 30 meters squared. So let's take, this is the original rectangle area. So this right now is equal to 30 meters squared. We know that area of rectangle is like base times height, right? So we're going to put this as like base as x at the moment. That means the height of this rectangle is going to be 30 over x. That's the first thing. Yes, flashed away. Type. I think I just got something in my email. Which one is this one? Let's have a look. Oh, yep. Okay, cool. We can do that as well, Type. I'll add it to the list, all right? How much time we've got? We got time today. So the first part is like understanding this. I think this is how you started off first, right? Now the second part is this. Now the length of the garden is to be reduced by 2 meters. All right, and the width is increased by 1 meter. Now you can do it either way you want, but I'm going to do it like this. So that's reduced by 2 meters, and the width is increased by 1 meter. So that means what we have is this new green rectangle. This green rectangle has an area of 28 meters squared. So I'm going to write it down a little bit here. So the green rectangle is going to look like this. But remember, the width of it is going to be 30 over x and 1. So it's 30 over x plus 1. And then the length is going to be x minus 2. And then what we have is the area is equal to 28 meters squared. Now, let me know if you guys want me to go through that part again, because this is pretty much the most important part of the question. Because if you get this part of this question correct, then the rest of it becomes pretty straightforward after that. So are you guys okay with this part here? And any questions here so far? Okay, I'm assuming we're okay because it's fairly quiet today. So that means our width now is 30 over x plus 1. So that can be written like this, 30 over x plus 1. Multiplied by the length, which is x minus 2, equals to 28 meters squared. Okay, now we treat it exactly like a quadratic equation, folks. So with a quadratic equation, what we do is we'd expand it. We're basically using the FOIL method here. So the first thing we're going to do is 30 over x times x, which equals to 30. And then we got 30 times over x times negative 2, which equals negative 60 over x. And then you got 1 times x, which is just x. And then you got 1 times negative 2, which equals to negative 2. And all of this is equal to 28. So at this point, you've got 30 and negative 2, which is, so we've got negative 60 over x plus 28 equals 28. Or in other words, we've got negative 60 over x plus x equals 28. Take away 28, and we end up with negative 60 over x plus x is equal to 0. Now, one of the things is, because you've got an x in the denominator with negative 60, what you can do is you can actually multiply every element by the numerator by x. All right, and this is a little trick that I like to use because it just makes getting rid of denominators really easy. So that means this ends up being negative 60 plus x squared equals to 0. Have I done a mistake here? No, maybe not. Okay, and then at this point what we have is x squared minus 60 equals to 0. So we can actually factorize this where we can say that x squared is equal to 60, or we can say x is equal to square root of 60, but it's going to be plus or minus. We can't really have x as a negative number because I think it's yeah, I think it won't actually work out. So we're going to do square root of 60, and we get 7.74. So therefore we can say that x is equal to negative 7.74 or positive 7.74. Oh, have I stuffed it up somewhere? Where did I make a mistake, Tony? Because I thought I made a mistake here. Isn't it negative 60 over x, x minus 28? How did you get minus 28? Wasn't 28 minus 28 0? Not gonna lie, your answer looks interesting, but we're okay? Yeah, I'm just looking back at my working because I know that there's only one negative 28. Now you can make it into a quadratic. Okay. Yeah, sweet. Okay, cool. We're gonna keep going down. Anyway, we've got x equals 7.74, and I think we just wanted to figure out what the dimensions of the new, sorry, I forgot that part of the question. But basically the question asks what's the new dimensions. So we've got x minus 2 and 30x plus 1. So if you remember, this was x minus 2. This is 30 over x plus 1. So the dimension is going to be 5.74. And we've got 30 divided by the answer, which equals to this, plus 1 equals 4.87. So that's our dimension for this rectangle, the new rectangle. That's what the dimensions are. Okay, are we okay with that, guys? And can we go to the next question, which is, I'm going to go to Tony's question because Tony just sent me a couple of questions. Let me know if you have any questions with this. William, if you're still in the stream, could you send me your question again, please? Because it's The image is not, it's broken, the link is broken, because I can see that you've sent me a question. Cool. So if we're okay with this, guys, we go to Tony's question, which is a discriminant one. So again, I think this discriminant question is going to be an excellence question. And again, if you haven't done much of discriminant work, don't worry too much about it, because like you just need to remember that the discriminant kind of ideas, and then you can kind of just work through the question after that. All right. Now I do mean this. Discriminant questions, they actually come quite often, and they're like not too bad, because once you figure out how to do the basics behind it, then it's just a bit of a like a standard bread and butter question. Okay. So in this question here, it basically says two distinct real roots. So if it's two roots, then what we're looking for is, the parabola looks like this, and it's going to have two clear roots. All right. Because of that, we know that b squared minus 4ac has to be bigger than 0. Well, have a go, Holly. Okay, so now just doing this part is not going to be enough, but I think if you want an achieved, substituting the b value, the a value, and the c value can easily get you an achieved. So in this case, a is equal to 1, b is equal to 2q minus 1, c equals 4q plus 2. So I'm going to substitute all these things right now. So b squared is going to be 2q minus 1 squared, minus 4 times a is 1, and times c is another 4q plus 2. And all of this has to be bigger than 0. J, the easiest way to look at it is like look at the which side the arrow is actually pointing to. The arrow always points to the smallest thing. So I'm talking about the symbol here. This is actually pointing to the 0, which means b squared minus 4ac has to be bigger than 0. Yep, Holly, just writing that is going to get you an achieved right there for sure. All right, that's your achieved, and then just solving this will get you a merit, and then writing the correct answer gets you an excellence. So I'm going to expand the bracket here. So you got 2q minus 1 times 2q minus 1, minus 4 times 1 is just 4, times 4q plus 2 has to be greater than 0. So now expanding the quadratic, I've got 4q squared, 2q minus 2q minus 2q, that's going to be minus 4q, plus 1, minus 16q, and minus 8 has to be greater than 0. Simplifying this, I've got 4q squared, minus 20q, minus 7, anything else, greater than 0. Okay guys, now at this point here, just use your graphics calculator. Okay, you can do this two ways. All right, I've always said this, like but the easiest method is just go into graph, just graph this equation, but instead of q, just use your, let me see if the mouse is back on. Oh yeah, here we go. So just use x instead of q, so 4x squared minus 20x minus 7, and just click on draw. Now obviously my calculator is kind of like set up in a different view window here, so just click on F3, which is the view window, and then change it to INIT. This usually kind of works. All right, and I can see the two roots. There's the first root, and there's that second. Those are the two solutions, right? So what I can do is I can click on GSolve and just click on root. So that first point there is negative 0.32, and the second point is 5.32. You could use either, Jay. It doesn't really matter. Like you could use graph, or I mean it's the same thing, man. Because all, like, see what I usually do is like this. I tell people to draw like a little quadratic like this, and the reason it's positive quadratic is because of the positive 4 here. Then what I do is I put a line like this called a 0, and there's my 2 points, 5.32. So this point here is 5.32, and then my first one was negative 0.32. So it doesn't matter which way you do it. You can find these 2 points by using polynomial or the graph mode. Polynomial, it's slightly easier because you don't have to mess around looking for the window, because polynomial, it just solves it straight away. Like, see, in polynomial, you can just go, where is it? Yeah, just type in 4, minus 20 and 7, negative 7. So you can kind of see the values real quickly with the polynomial. AJ, I think if you got physics, jump off my stream, man. Go do some physics work. The stream will be uploaded later on for you. So, I mean, with the graph, it just helps you look at the picture, but it doesn't really matter. Anyway, we're looking for when is this quadratic bigger than 0? Well, we can see that it's bigger than 0 here and bigger than 0 there. So to write it down, I'm just going to write down the and 5.32 and negative 0.32. Put my 2 arrows and X. Oh, yep. Hey, William, I'm just going to send you a link for the log questions, because I think I've actually done this question before, or a similar one, but just give me a second. Jay, you were asking me, you were struggling with the arrows, right? No, you can straight away go from here to this step if you're comfortable. Yes, that would get an excellence type. But the reason I actually do the diagram is because the diagram actually helps me to write it in the right notation. Like, what I do is I put down the 5.32 there, I put the negative 0.32, and because it's 2 different zones, I have to put the and. All right. Yeah, so that's why I do it like this. It just okay. Hang on a second, Jay. I'm gonna find two videos that I did that'll help you with this. When did I do this? Tourist attraction. Okay, Jay, you know the notebook? Like, I've actually shared a link in the description here, right? In the description, I've actually shared a link to this notebook that I'm currently working on. And I think the tutorial that I did was on 4th of September. If you go and have a look there is, like, that video basically covers all of the discriminant stuff. But more importantly, I think it covers, does I cover that? Where did I cover it? I'm just sorry, I'm just having a look at it. Yeah, so it covers like different variations of that question that we've just done. So it teaches you how to write in different ways, but I think I also did it a couple of other times. Let me just double check. Yeah, and also check out the 17th of October one. No, Tony, that is not acceptable. That's not how you write that. That's actually incorrect, because the way you've written that answer is you're saying, you're actually saying that you're looking for a number that's actually bigger than 5 and smaller than negative 0.32. Carlos, you'll have to use a quadratic, you have to use quadratic formula for that, Carlos, to try and solve it. So you have to put A as 4, B as minus 20, C as minus 7, and then work out the x values. But let me give you guys a hint, all right? Like, look, there's only two situations that can actually happen. So say, for example, okay, I'm just going to show you a different question, right? So if they say something like you've got a quadratic, all right, this is what that final quadratic actually looks like, right? And let's say if it's positive, then you're actually looking for these two things. If it's negative, you're actually looking in, because this is what the graph actually looks like, where that's positive, that's negative. Then let's say, for example, this number here is like -3 and 5, and this number is -3 and 5. All right, then what you do is, if for the first situation, as I said, because it's got two zones, I'm going to put the and I'm going to put -3 and +5. The arrow always points to the left, and then just put x on the other side, because this is saying that x can be 5 and above, or x can be less than 3. As for that second situation, it's x is between -3 and 5. So I'm going to write -3 first, 5. X is actually between these two numbers. So I just point out the two arrows like that. That's how you finish off that question there, Jay, because it's only two situations that's going to happen. It's either going to be left or right. So you just need to kind of practice that a few times to actually get that, how to write the zones properly. Where is that question that we did? Okay, William, I haven't actually done that question, so I will try and do that. Is that okay, guys, with that question? Because I'm telling you that's all that there is to that question, all right? Like, the only other thing that you guys need to be careful about is if on the odd occasion you'll have the discriminant less than or equal to 0. So just need to make sure you put the symbols as less than or equal to. But apart from that, these are the only two ways that they could potentially ask that question. Okay, are we okay with that question there, guys? Sweet. So this is, I'm looking at the next question here. I think this is by Taif. I'm just going to copy it. Give me a second, man. Let's chuck it here. Got a nice mixture of questions today. It's quite cool. I actually like this. Don't have to stress about finding questions all the time. All right, so this is question 5 today. Great. We got a pen problem. Where is it? Having some technical difficulties. I lost my pen. Where's my pen? I'll figure it out. J. Oh, is this one here? Is it? Because I might have actually done it then. Oh, this one is level 2 for sure. Okay, so let's actually do this one quickly, all right? It shouldn't take us too long. What we've got is just a couple of things to kind of notice, all right? This is, I mean, it's a good idea to actually know this as well, guys. So you've got a quadratic equation. Now at the top there, that is worth 16 meters. The next thing is the maximum depth is 16 meters. So that part is 16 meters. Now it says the base of the canal is flat and has a width of 12 meters. So that 12 meters is this part right here. So they want to know what is the actual depth. I don't know if I've actually done that 2012 paper. I can't remember. Have I done the 2012 paper? Because if I have, then it's no point doing this question. Let me just check if I've done that question before. I don't remember going that far back. No, 2015. That's it. I've only gone back to 2015. Okay, now cool. Sweet. So let's go through this then. So what we can do is we're going to have to create a quadratic equation first, right? Now what I'm going to do is I'm going to put this as let's see. What can I do? I'm going to put it like this. So this is going to be 0, 0, 0, which means this point here is going to be 8, 0. This one here is going to be 0, 16. And this one here is going to be 16, 16. Nah, it's all good. Hey, friction. So we've got 3 points here, which means we can actually come up with the, you go into your graphics calculator to come up with the equation of the quadratic. But, you know, I mean, I think I will just do that quickly, but I will show you guys how to do it without it as well. So you got 0, 8, 16, 16, 0, 16, graph 1, calc, and we got x squared. So that's what our equation is going to be. Y is equal to negative 0.25 x squared minus 4x plus 16. So now that's the equation, right? Now it's actually asking us to find that red distance. Now the red distance, we kind of have to kind of work out backwards really. So what have we got? If this is going to be 12, then that there is going to be 4 meters, or like 4. No, it's not going to be 4. Hang on. That's going to be 6 wide. So this is going to be 2. And then this is going to be 14. Yes, flashed away. I'm going to show it on the side here. So you can actually use the vertex form. So the vertex form looks like this. So you've got y equals a x minus h squared plus v. Now you might have actually done it slightly differently, but basically that h value is this one here, and the v value is that 0. So we can rewrite this as y equals a x minus h squared plus 0, and then substitute the point. It could be 0, 16 or 16, 16. I'm going to use 16, 16. No, actually, I'm going to use 0, 16. Which means 0 gets substituted here, 16 gets substituted here. And you've got 16 is equal to a times 0 minus 8 squared plus 0. Well, I don't need to worry about the plus 0. So 16 is equal to a negative 8 squared. 16 equals a times 64. And then a is equal to 16 divided by 64. What have I done wrong? Something's not right here. Why am I getting a negative value for that? Did I copy that wrong? Oh, I did copy it wrong. That was supposed to be positive. There we go. So from here, you can see that a is equal to 0.25. So you can write your equation like this, 0.25 x minus 8 squared. So both of these equations that I've written here are the same. And we just got to substitute x is equal to 2 first, or 14. It doesn't really matter. Because the reason I've done that is because 8 is halfway, and I need to go 6 this way or 6 this way, because that length is 12 meters. So I'm talking about, because this length is 12 meters, I need to go 6 forward or 6 backwards. If I go 6 forward, I get 14. If I go 6 backwards, I actually end up with 2. So I substitute 2 in. So I'm going to get y is equal to 0.25, 2 minus 8 squared. I got y is equal to 0.25 multiplied by negative 6 squared. So 36.9 is what I get. Now that 9 is the height from there to there, which means the actual depth is going to be 7. Because remember, 16 is how long it is. So we've got to go 16, take away 9 meters to get 7 meters as the final depth. All right, guys, is that okay with that question? Just picking up your question, William. Could you show how you did the equation though, like with the graphics calculator? Friction, we're just doing like a whole lot of algebra questions. Just people are just sending me questions and I'm just kind of working through them. So, Taif, what I'll do is I'll actually show you, I've got a video set up on how to actually calculate that, like how to use the graphics calculator. Where is it? You want to do quadratic equation given 3 points. This is the video you're looking at. So Taif, just check out that link that I've just posted on the comment section that has a video of how to actually go through this type of questions. Cool. So William, this was your question, and I think this is probably the last one for the night. Now, the reason I've actually I've been wanting to actually do this question is because this type of question is always been coming in the exams. All right, they're a simple log question, and it is, yeah, it's literally just substituting a couple of values or just rearranging and just finding out what or when t is. But I'm going to show you guys how to do it anyway. Just before I get started, yeah, Jay, I think we did that slightly differently, but I think we still got 7 meters. So we're all good. So you can actually do it. So there's so many ways of doing that last question, Jay. But as long as we get to the final answer of 7, we're all good with that. Flashed away, you didn't send me the question in that email. Like there's no attachments. It's an empty email. Oh, Jay, like, yeah, I mean, sorry, I'm just gonna go back to that question there. Like, see, what they did was they just had the origin in a completely different area, that's all. So if you go back to the original diagram, like you could have done it like this, where this is like 0, 0 as one way, or some people might like to do it, you know, where they put something like this, where they put the origin here. So it really doesn't matter which one you use as the origin because it's all like relative. Okay, is that all right? Coming back to William's question, kind of go through this at the moment, all right? So all we have to do is, what do we got? Tourist attraction, blah, blah, blah. Number of visitors can be modeled by this. It says how many more people visited the gardens in its 6th year compared to the 4th year. All right. So all we got to do is we just got to go P is equal to 7,500 times 1.08 to the power of 6 minus 1. That gives you for the 6th year, and then do it again for the 4th year and just subtract the two of them together. So in other words, you could actually do 7,500 times 1.08 to the power of 5 minus 7,500 times 1.08 to the power of 3. And whatever that is, that ends up being your answer there. Times 1.08 to the power of 5 minus so 1,572 people. Now, Tony, level 2 calculus is actually a lot easier than level 3 calc. Most of the times people struggle with level 3 calc is not because it's because of the algebra skills. You just have to like be really good with your algebra skills. All right, so part 2 of the question, in which years did the visitor numbers reach double the number of the first year? So this one, William, like here's something that you guys, that actually helps you guys out, all right? Oh man, I hate this blue color, it just pisses me off. So when, like, if you look at this one right here, right, what we've got to do is we've actually got to figure out how much people were there in the first year. So what we're going to do is we're going to put down number of the first year. So when we put t equals to 1, we need to figure out how many people are there. So 7,500 times 1.08 t minus 1. So we are going to get times 1.08, 1 minus 1. 1 minus 1 is 0, so anything to the power of 0 is 1. So our p is equal to 7,500. All right. Now, if you want it to double, we're trying to figure out when is it going to reach 15,000. So we can go 15,000 equals 7,500 times 1.08 to the power of t minus 1. So rearranging this, we're going to get 15,000 divided by 7,500 equals 1.08 to the power of t minus 1. So in other words, we get 2 is equal to 1.08 to the power of t minus 1. Now, at this rate, we want to take logs of both sides. So we're going to get log 2 equals log of 1.08 and t minus 1 in the power. And remember that you can actually bring the power to the front. And when we do that, we're going to get log 2 is equal to t minus 1 multiplied by log 1.08. And then t minus 1 is log 2 divided by log 1.08. And of course, don't forget to bring the plus 1 to the other side, or the 1 to the other side. and this gives you what your t is. So you've got log 2 divided by log 1.08 plus 1. So it's about 10.006 years. William, is that all good? Yeah, William, the first part is achieved and the second part is definitely excellence. Because any kind of log questions where you're trying to find the power ends up being an excellence question. And I think if you have a look at my tutorials, particularly the one that I did previously, log questions extended, so there's a lot of questions there going through some of those excellence type questions with interest rates and things like that. So that's if you go back to my playlist, you can find log questions extended. All right, guys, I think I've got time for one more question. I know somebody put it and then they forgot the question, so let's have a look. Actually, this question is really, really useful to have. Flashed away, are you talking about question 1A? That you just sent me, or question 3A, or whatever it was. Okay, yeah. Now I'll do that real quickly because a lot of people struggle with that question, but it's actually really, really easy. And I mean like super easy. Oh, actually, no, maybe not. This is a different one. Oops, sorry. It's all right. We'll show you guys anyway. Okay, so this is the question that Flashed Away actually sent us. Now guys, I want to show you guys a little bit of a hack here, all right? Now this little hack here, it works pretty much 95% of the time. But let me show you guys how to do this question here. This question here, see, you've got ax squared plus bx plus c, and it says it only has one solution. All right, the key is that it only has one solution. Oh yeah, I'm curious now how you guys would do this. Just use discriminant. You could use discriminant, but how are you going to find the values of a, b, c? Because if it only has one solution, then we know discriminant of b squared minus 4ac equals to 0. All right? But that doesn't really help us much. But what we can do, yeah, Tony, that's what I'd do. Because one of the solutions is equal to -2/3, what I do is I actually rearrange this. And I cross multiply and I make this to 3x is equal to -2. Switch the -2 to the right hand side to make it +2, and this equals to 0. So in other words, what I have here is, because it's only one solution, this could be written as 3x plus 2 times 3x plus 2. Because think about it. Because if 3x plus 2, if it only has one solution, then we know one of the brackets is equal to 0, and then eventually we get to x equals -2/3. But what we're doing is we're kind of going backwards, and we're ending up with 3x plus 2 squared. So expand the bracket, which means you get 9x squared, 6x and 6x is 12x plus 4, and that's your final answer. Yeah, that's basically it. But I want to show you guys another one as well. Sometimes they do something like this, where they have a question like this. Well, they'll have like a quadratic equation. I'm gonna make this up. It might not actually work out. So give me 1 second. I'll just get a question, because I've seen this pop up a couple of times and people get kind of stuck in it. So what they do is sometimes they say it's like this quadratic equation. It looks like this: 6x squared plus kx minus 2 with solutions x equals positive half and negative 2 over 3. Find k. Jay, yes you do. I would actually put that, yeah, for the previous question I would actually put a equals 9, b equals 12, and c equals to 4. You never know what they ping us for. Now as for this question, question b here, if you want to figure out k, what's the easiest way to do it is just substitute one of the values to where x is, and it has to equal to 0. So what we're going to get is 6 times half squared plus k times half minus 2 should equal to 0. So 6 times 0.5 squared is 1.5. So 1.5 plus k over 2 minus 2 equals to 0. And what we've got is k over 2 minus 0.5 is equal to 0. And then rearrange it. K over 2 equals to 0.5. K is equal to 2 times 0.5. So k is equal to 1 in this case. Yep, that's basically it. Alright guys, that's all the questions for today. As always, I'll hang around for 5 minutes if you got any kind of urgent questions. But I'm not doing any more questions after this point here. But that's us for today. No worries. And as always, this will get saved so you guys can actually watch it later. For those of you that kind of joined halfway through. You're welcome, Brad. Tomorrow's Friday, man. Friday and Saturday, just chill out a bit. Mr. Lands, I did one yesterday, I think, for tables, equations, and graphs. I know a few people have asked me for geometric reasoning, which I might do. So it depends. I mean, if tomorrow, if my missus is tired and she goes to sleep and doesn't want to watch a movie, then yeah, why not? Yeah, you're welcome, Jay. So if you have any questions, just keep popping it out, because I know I owe you a few questions from a couple of months ago, but it's just been a bit flat out. Alright guys, if that's it. Oh, that definitely was, Tony. Don't even go there. That was possibly one of the most craziest paper that I've actually done in a very long time. Did you guys prefer this session where you guys were actually sending me questions and then I can just do it on the spot? Or do you prefer me working with it like themed questions? It has a lot of meanings for me, Taif. I mean, it has different meaning. Yeah, I like this one too. It was actually quite a bit of fun, like just not having to look for questions for you guys. Now I'm running out of questions at the moment because like I have to, usually with the tutorial, I have to spend like half an hour beforehand creating questions, and then sometimes the numbers don't work out and I just get frustrated. But it's always nice when people just put a few questions up, then I can just kind of just go, yep, I know what I'm doing, and then just get it done and dusted. Figure out what happened here. Lewis. Normal distribution, it's stats, man. I'm not touching stats at the moment because if I touch stats, no, it's not that I don't know it. It's just like I'm trying to keep away from it because it's just a lot of work. Because then I have to do like 2 extra tutorials a year. And plus, I get some others people to actually do the stat stuff. Yeah, normal distribution is like too easy and good bit of fun, but not as much fun as I have with algebra. Yeah, I mean, like back in my day, we didn't even have a graphics calculator for normal distribution. Now you can do everything in graphics calculator for normal distribution. And stats is pretty important, man. It's making a comeback, big comeback. All right, guys. I think that's basically it. I will. If you're doing physics tomorrow, you shouldn't be up. Go get some sleep. I will catch you guys next time. All right.